Welcome back. So today we are going to start our conversation about single variable data. I'm going to focus on a quantitative one, and I'm going to work with a small set of data because I'm going to do things by hand to show you how things work. Whatever works for small data would work for large data. The process is exactly the same, but I don't want to waste time, so I'm working with very small data sets. There are three things that you always have to pay attention to when you work with a single variable quantitative data. One is called the center, and the second one is the spread, and sometimes we call it the deviation, and then outliers, okay? So that's what I want to focus on today. So let's pretend we have a variable, I called it x, and I want it to stand for a random variable that represents annual income of 5 people. So let's say you have a small company. It has 5 people total, the founder and 4 employees. That founder decides to pay himself or herself $800,000, okay? But pays his or her employees $50,000 each. That could happen, right? And we want to look at this set of data. Again, it's only 5, and the number of observations is only 5 because I don't want to waste time. But it doesn't matter if it is 50,000 employees or 5 employees or 20. The process is the same. So notice that this founder, this CEO or president, pay himself or herself a large amounts. And very quickly, I'm very sure you know what we call so-called average. That is really called arithmetic mean. Sometimes it's called the mean of x or just x bar, okay? And that is 50 plus 50 plus 50 plus 50 plus 800 divided by 5 numbers, right? So that gives us an arithmetic mean of $250,000. So that's the first one. That's called the mean. People would call it average. You shouldn't call it average. You should call it the mean. The word center has another name called average. So if somebody says to you, what is the average? Your question would be, which one? There are 3 of them, okay? So it's called mean or arithmetic mean. The median is basically the middle number if you rank your numbers from low to high or high to low. I happen to rank them from low to high. And the median is just the middle number. So I have 5 of them. The middle number is this 50. So that's median is this median here, is this number here. Sometimes we call it Q2 or second quartile. I'll write it down. Second quartile. And sometimes we call it the 50th percentile, which means 50% of employees got paid more than $50,000 and 50% got paid less than $50,000. It makes sense. So the median is this number. There are 2 employees or 2 people get paid more and 2 people get paid less. That's 50% and that's 50%. Now, if this number happens to be 5, the number of observations or income is 5, right? If this number is even, let's say it's 6, you just have to find the mean of the 2 middle numbers, and that would be your median. So for example, let's say you have 6 values. 1, 2, 3, 4, 5, 6, okay? And they are in order from low to high. This is low and this is high. You could also rank them from high to low. It doesn't matter, but they have to be ranked though. So if I say to you, what's the median? You'll say, well, there is no median, right? So what you do in that case, you take these 2 numbers here and you find the actual mean, or what we call sometimes average, right? That's average or mean would be your median. And of course, that median is not one of those 6 numbers. This median was this one. But if I have 6 or 10 or 1 million numbers, which is an even number, the median is not one of those numbers, just a new number, okay? So that's how you find the median. And I'm very sure you know these concepts, but it's gonna get hard very quickly, okay? So pay attention. The mode is another average. It's just the most frequently used number. So we have 4 50s and 1 800. If I were to do a little graph, it looks something like this. So I have two numbers. One of them is called 50. I'm going to use a bar graph, 50K, and then I'm going to use 800K. These are the only two numbers I see here, right? There is the 50 and there is the 800. So this would be the annual income. This is the income. And this one will be the counts or the frequency. How often did it happen? So 50 happened 4 times. So let's say this is 4. Okay? And 800 occurred once. So this is not drawn to scale. So 4 of those will give you this one, right? So clearly the mode, the highest used number is 50. So this 50 has nothing to do with that 50, okay? This 50 is just the most frequently used number, okay? Now, generally, we don't even use the mode. We hardly use the mode. The most important centers are the mean and the median, okay? The mean and the median. So that's a quick introduction to the center. Now, notice that the mean is so different from the median. I'm not going to pay attention to the mode, okay? So my first question to you, and I would love for you to freeze the video and answer this question for yourself. Which average best represent people's salaries? And of course, always, and why? Okay, so stop the video and figure out, is this the right number to represent these salaries, or this is the right number that represents these salaries? And the second question, why you choose what you choose, okay? So I'll see you in a little bit. Okay, so I hope you all thought the median was more representative of the annual income than the mean. The question is why? The reason the median is better is a better representation of the center is because we have this weird looking annual income. So let's say this person was invited or is invited at Oprah, okay, and she want to know about, let's call it Mrs. X, okay. So Oprah asked Mrs. X, tell me a little bit about your company. And Mrs. X talks about the company, and then Oprah says, what is an average income at your company? And Mrs. X says, oh yeah, our average income is $250,000. Now she would not be lying, because she is referring to the mean, but it's kind of misleading, isn't it? Clearly, the so-called average salary, although the mean is $250,000, if you were in the audience listening and Mrs. X says, yeah, on average we pay around $250,000, people in the audience would want to work for you. Then they show up and you hire them and you give them $50,000. And then now they're shocked. Like, what is this? I thought your annual average is $250,000. And Mrs. X said, well, I didn't lie. I was talking about the mean. Well, yes, she didn't lie, but she actually stretched the truth. The key is, in this case, you would have to focus on the median, because we have this weird looking number. This number is what we call an outlier. It's a number that is outside of the norm, outside of the data sets. It's outside of the pattern. So there is a lot of 50s, 49, let's say, $62,000. But then we have this weird looking number called $800,000. So the moral of the story is this. Number one, when you talk about center, you need to think about three things. Number two, if you have a presence of an outlier, you really need to think about the median, because this generally represents, that Mrs. X would say, yeah, our average salary is $50,000. Yeah, I think that's fair, right? Even though she pays herself $800,000, this is a much better representation of a center or average than the mean is, okay? So that's the very first myth or a way to mislead people. And people do this all the time, by the way. You go to a city and let's say you wanna buy a home, and the realtor just want to sell you a house because that's how they make commission. So let's say you have few homes that are worth $7 million in that small town, and the median price is, let's say, $200,000. But those few homes that are worth $7 million will push up the mean. So the mean might be, I don't know, 650, but the median is only around 200. And she said, well, look, our average is around 650, but I just found you a beautiful house for 300. Well, that's a lie, okay? Because the median is 200, not 650. And that's why if you look at home prices in your city, you should always focus on the median. You should never focus on the mean, because there are few extremely expensive homes or few, mobile homes. They cost almost nothing. And if you add them into the equation, then they will drop the mean so badly. You want to focus on the median. So that is the moral of the story. Now, the question was why the median is a better measure than the mean. We just talked about that. Now, outliers, as I said, are data values that are outside of the pattern, outside of the norm. If you are trying to survey people, you have a job to call people and ask a particular question, let's say a political question, and you want to ask about their age. And people, they say, I'm 30, I'm 49, I'm 50, I'm 23, I'm 68, right? And one person says, I am 150. So that is an outlier. That person could not be 150. And it is so important to pay attention to outliers because they can skew the data, can't they? This particular outlier really messed up the mean. If this 800 wasn't there, the mean will be very close to the median, if not equal. But this 800, which is an outlier, skewed the mean. It actually pushed up the mean. Outliers, think of outliers as human beings pulling the mean toward them. So you have numbers like this. Okay, watch this. So let's say you have numbers like this, okay? And the mean might be here. The median might be here. But then let's say we add an outlier here. Now, the median most likely is going to stick around here, but the mean is going to be pulled. It's going to be pulled. The outlier pulls the mean toward it. So if the outlier is on this side, the mean will start moving in this direction. But the median generally stays put. We say medians are resistant to outliers. The means are not. So whenever you have an outlier or a potential outlier, you need to pay attention. Now, sometimes those outliers are just errors. The person said, you heard 150 years old, or you heard 150, and you wrote, you heard 15. So you are recording people's ages, and somebody says 115, and you wrote 150 on error, or you put a dot without thinking about it, right? So sometimes they are due to errors, but sometimes it doesn't matter what the reason is. You need to know which are the outliers, and you need to learn how to deal with them, as we will see. So how do you choose which average? Well, as I just said, if there is a presence of outliers, you want to focus on the median. So if the distribution is symmetric means looks like, symmetric distribution looks something like this, or it looks like this, or looks like that. These are symmetric. Or looks like that, or like in our previous example, we had 50 and we had 800. That's not symmetric. That belongs here. That's called asymmetric or skewed distribution. So in our case, it might look something like this. That looks symmetric, for example. It doesn't have to be exactly the same, but that looks fairly symmetric. So distributions that are symmetric, which average do you use? Actually, it shouldn't make a difference. You could use the mean, you could use the median. They're going to be very close to each other, if not equal. But if the distribution is skewed like this one, for sure, right? Or something like this, like y equals 1 over x, if you remember. That looks very skewed to the right. It's skewed to the right. Or something like this, right? Any non-symmetric distribution, you have to focus on the median, not the mean, because the mean, like in this distribution here, let's say the median is here. Let's say the median is here. Where do you think the mean is going to be? To the right of the median or to the left of the median? It would have to be to the right of the median. I don't know where, but it's definitely to the right, because this distribution is skewed right. Skewed right. And if it is skewed right, the mean gets pulled toward the skewedness, toward the outlier. And therefore the median will be higher than the mean will be higher than the median. Okay? If it is symmetric like this one, look here now. If it is symmetric, the mean might be here and the median might be right next to it, if not equal. They will be very, very close to each other, if not on top of each other, okay? So that is important to know. So let me erase this. It's a little messy. And then we will continue. So now while I'm erasing, let me just summarize. If the distribution is symmetric, which average do you use? It doesn't matter. They're both basically the same, mean, median. We don't care about the mode. If the distribution is skewed, you really want to focus on the median, just like here. This is skewed because of this outlier. The median is a better representation of people's salaries than the mean. Okay? So that's that. Now, we're going to move on to spread. Oftentimes we measure the spread by the standard deviation. The standard deviation, so let me explain to you the importance of spread first, okay? So let's say I have two classes, your class, data cubed 1 and data cubed 2. Let's say I only have 3 students in each class because I don't want to do too much calculation, okay? I know you're like 19 or 20, but I'm going to pretend there are only 3 of you. And I'm giving a test to each class, and I'm giving 3 tests, or a test to each student from each class. So this is class 1. So this is my random variable. I used X here. I chose to use Y here. So don't get scared of Y. It's just a variable. It's a random variable. I called it Y subscript 1 because I have 2 classes. Okay. I don't want to say Y, then you wouldn't know which Y I'm talking about. So let's say for my first class, my students received 60 out of 100, 80, and 100. And in my second class, my students received 79, 80, and 81. So what I would like you to do is to compute, you could do this in your head because I picked really nice numbers, compute the average. I put average in quotation marks because I'm asking you to decide which average you should think about. Then I said, which one would you choose and why? Well, just by looking at this distribution, it looks fairly symmetric, and it looks fairly symmetric. So which average? Well, yeah, you could use the median, you could use the mean, it doesn't matter. Let's use the mean. So the mean will be 60 plus 80 plus 100 divided by 3. So that's 80. So that's the mean. The mean here is 79 plus 80 plus 81 divided by 3, which is also 80. By the way, the median is also 80, and the median is also 80, but that's irrelevant. So what we have here is the median is 80 for the first class, and the median here is 80 for the second class. They have the same mean. They happen to have the same median. Which one would you choose? The answer is, it doesn't matter. My question to you, and I really want you to pause the video and answer this question. Which class is doing better? So I teach this class, and my average, so-called average, in quotation marks, is 80. My other class has an average of 80. Well, to me, they look the same because they have the same average. But I'm asking you, which class is better? What does better mean? Because I just said the word better. What do I mean by better? Is the average a sufficient measure of student performance? This question can be answered based on your answer to these. So I would like you to pause the video, take a good 4 or 5 minutes, and jot down which class is better. If you were the teacher, which class would you consider a better class? Second question, what does better mean? What does better mean? And of course, by answering these two, is the average, in our case the mean, is the mean a sufficient measure of students' performance? Okay, so pause the video, please. All right, so I hope you answer those questions. Well, they have the same mean. That doesn't mean one class is, the performance of one class is the same as the other class. So which class is better? I hope you answered this one. So imagine you're the teacher, and you're teaching very strong students and weak students. How hard would it be compared to this one? This is more of what we call a homogeneous class, right? So that's why your school, they split you by, like Algebra 2 together, those in advanced course together, because there is less variation among the student's ability. Now, I'm not suggesting that test scores represent your ability. I'm just loosely defining this class is definitely better class than this one. And this class is actually easier to teach than this class. And this class is easier to learn as a student as compared to this class. Imagine you're in this class and one kid is just like jumping up and down with answers and the other one is so quiet. Again, I'm very loosely using grades as a measure of ability. I know it's not true, but just bear with me for a second. You're sitting here, okay? You're so-called an average student, and there is a weak student getting, let's say, 30 points consistently, and a kid who's always getting 100. You'll go nuts because this one is like, I don't understand, and this one is like, I'm bored, right? So it's easier for students to be in this class. It's easier for the teacher to be in this class. Why? This is a homogeneous class. This is less of a homogeneous class. Now again, this is loosely defined. This is just one test. I am saying that tests is a measure of ability, which is not true. I'm just playing with small numbers because I really don't want to waste time calculating. So how do we figure out now which deviation do you want? Do you want a small deviation or a large deviation? That's the question. The answer is, of course, you want less of a deviation. You always want less deviation. You always want less uncertainty. If I can tell you that we're going to open campus in the fall with 90% confidence, that's a much better feeling. I'm talking about the COVID-19. It's a much better feeling if I say we're going to open campus in September and with a really a good probability of 13%. What a joke, right? You wouldn't trust it. If I say, look, I want you to bet $1 million and there is a 30% chance you're going to win or you're going to make money, you're not going to have a good feeling. But if I say, look, you could bet $1 million on buying this stock and there is a 95% chance that you are going to make money, that's probably a good feeling and probably you're going to invest that money. So how do we measure variability or spread? I put the formula down here. So any variable, any random quantitative variable, the way you figure out the variance is called the variance. You take every observation and you subtract the mean from it and you square it and you add them up. So for example, if you look here, you take 60, you subtract 80 and you square it. And then you add 80 minus 80 squared plus 100 minus 80 squared. That's what I did here. Okay, first observation minus the mean, not the median, okay, squared, plus the second observation minus the mean squared, plus the third observation minus the mean squared, and you divide that by number of observations. So you divide that by number of observations. Now, I don't want to get into n and n minus 1 for now. Sometimes we divide by n minus 1. Don't worry about it at this point. So you just divide by the number of observations. So if I compute this variance, I get 266.6. Now, this variance is not very useful. If you just think about the units, okay? Points minus points is still points, right? 60 points minus 80 points is points. Square points, it's points squared. You add points squared, you get points squared. Divide by a number, it's still points squared. That makes no sense, right? What does it mean, 266 and a 2/3 square points? Then you might say, well, why are you calculating the variance if it's not important? Because I calculate the variance to find what I really want, which is the standard deviation. What is the standard deviation of my variable? It's just the square roots of the variance. So if you take square roots of 266.6, you're going to get 16.33 points. If you take square root of points squared, you get points. That makes sense. Again, we don't care about the variance, but we need the variance to find the standard deviation. Okay? So now, what does this number mean? Because that's what really I care about. I don't care about this one. For this class, the standard deviation is 16.33 points. What does that mean? It means that on average, these 3 points are away from the mean by this much. On average. So you have 60, you have 80, you have 100, and my mean was 80. This is the mean. So this is 0 distance from, this is 80, this is 60, this is 100. I really hope you pay attention. This is really crucial. So this is, let me erase this. I'm going to put the mean in red, okay? So this is the mean in red, okay? So this number, 80, is 0 points away from the mean. It's literally sitting on it. This point is 20 points away from the mean. It doesn't matter if it's on the left or the right, okay? So don't worry about negative 20, just say 20. So 20 points, 0 points, 20 points. So on average, they are about 16.33 points away. Even though this is 20 and this is 20, but that's 0, drop the 20 into 16.33. So on average, I'll repeat. What does this number mean? That on average, the three data points in blue are away from the mean by this much. Now, is that high? I think it's high. On average, the 3 scores are 16 points away from the average of the mean of 8. Yeah, I think it's high. Now, what do you think the standard deviation of this one? Do you think it's going to be smaller or higher? Of course it's going to be smaller, much smaller. This is a much more compact set of grades than this one. So let's compute that quickly. I call this y2. So what's the variance of y2? The first point minus the mean squared plus the second point minus the mean squared plus the third point minus the mean squared divided by 3. I got 1 plus 0 plus 1 over 3. I got 0.6 bar square points. The standard deviation of y2 is just the square roots of 0.6 bar, or square root of 2/3, which gave me this much. What do you think now? So my points are 79, 80, 81, okay? And my mean is 80. So this point is 0 points away from the mean. This point is 1 unit away from the mean, and this point is 1 unit away from the mean. They're very tight. They're very close to the mean. I should maybe just put it here. It's literally sitting on that blue dot, right? It's sitting right on that blue dot. So clearly, the standard deviation here is low. So what does this mean? It means those three scores, on average, they're about less than 1 point away from the actual mean, called 80. So definitely, this is a much better class, more homogeneous, has a lower standard deviation. This is how you say it. This set of observations have a lower standard deviation compared to these data points. Okay, and this is the formula for the variance. And if you want to find the standard deviation, you just take square roots of this stuff. So find the variance first. Once you finish, take square roots and find the standard deviation. Okay, so what if I'm going to conclude with one more concept quickly. Well, maybe my class is 3,000 students, right? I really don't want to do this by hand, would you? So on your calculator, you can repeat everything I just did with those three scores. So you go on the graphing calculator. I wrote 1. I meant to say on. Sorry. On the graphing calculator, you go to stats. You click on edit. And you get L1, L2, L3, L4, L5, L6. You go under L1, and you input those three values, 60, underneath 80, underneath 100. And you go back to stat again. You go to the right where it says calc or calculates. You click on one var stats. We're dealing with one variable in this case called student grades. We're not comparing a variable to another. We're dealing with one variable. So you go to one variable stats. It's going to ask you which of the column L1 through L6 do you choose. You're going to choose L1. The default, by the way, is always L1. So if you put it under L2, you make sure you write choose L2. Otherwise, it's going to be L1. And you click on calculate, and you're going to get a bunch of numbers. And I'm not going to work with all of them. I'm just going to point out a couple of them. The ones I want you to double check is the mean, right? And then I want you to go to the standard deviation. Standard deviation. This is also a standard deviation, but we're not going to deal with it at this point. So this is the one I just computed here. Here, this one, and this one, okay? So I want you to double check your standard deviation. And here is the median. This is the median. Q2, right? It's the median. It's important to know that these numbers exist because we're going to address them later. Minimum, Q1, Q3, maximum, and the median, of course. These 5 numbers are essential. But for now, I want you to double check the mean. I want you to double check the standard deviation and Q2 for both sets to see if you're going to get the mean of 80, median of 80, mean of 80, median of 80, standard deviation of 16,333, and a standard deviation of 0.816 after you do this. It should take you no more than 3 minutes. Double check it to see if it works. Why this is important? Because if the number of observations is large, you really never, ever, ever want to do it by hand, okay? And finally, I'm going to conclude with a homework assignment. So here is your homework assignment. I want you go on the web, go on Yahoo Finance. You could just type finance.yahoo.com and pick a company that you are interested in. Apple, Microsoft, Amazon, General Electric, whatever you want. Maybe something you have interest in, maybe something you have passion for. Could be technology, could be utilities, could be finance, consumer, whatever you want. And I want you to type the ticker. The ticker is the symbol. If you don't know the symbol, let's say you're interested in Apple, just go on Google and say Apple ticker. And it's going to say to you, let me write this. It's going to say AAPL. Let's say you're interested in Microsoft. If you don't know the ticker, type up ticker, Microsoft, and it's going to give you MSFT. General Electric, GE. I don't know what you'll be interested in. McDonald, T-Mobile, T. What am I thinking? Berkshire Hathaway, BRK, either A or B. Whatever company you're interested in, type the ticker, okay? And you'll get a page. Slightly at the bottom, pick historical data, okay? And it'll give you a bunch of data, like prices, day by day, today, yesterday, day before. You can go back as far as you want. Cisco, CSCO, whatever. I don't want you to pick daily. Right underneath, on the right, it'll ask you how frequently. Do you want it daily or weekly, monthly? I want you to pick monthly. And it's going to give you the list of prices of the company that you choose on a monthly basis. July 1st, June 1st, May 1st, April 1st, right? I want you to take those last 2 years, which means 24 numbers. So it's easy to type 24 numbers. Go on your calculator under L1, go back here, Stats, Edit, under L1, and copy those 24 numbers. Starting probably today, right? Today is July 8th or 9th. So you're going to type, it's going to say July 8th, June 8th, May 8th, April 8th, March 8th, right? February 8th. Copy those 24 numbers on your L1 and go through this process. I want you to find the mean, the median, and the standard deviation, which means this one, and this one. And then just eyeball it and see if you could identify a potential outlier. What is a potential outlier? By the way, which numbers I want? I want the opening price, because you'll get the opening price, the closing price, the lowest value, the highest value. I just want you to pick the opening price. Like today, the price opened at $39.46. Okay. Potential outliers to the naked eye. So let's say the prices month by month were like $39.42, $40.25, and one day it says $100.22. That's probably an outlier. Or at $3.23. Maybe that's an outlier. Maybe that happened on March 2020 when the market crashed in March. Sometimes March 19th or something. So that might be a potential outlier. That's what I mean by an outlier, okay? Then I would like you to interpret those numbers in context, just the way I did it today. I explained to you what does this number mean, right? I said on average, these three scores are this much away from 80, right? So make sure you interpret those numbers in context, and then based on the numbers that you found, I would like you to draw a conclusion about the shape of the distribution. You haven't graphed it, you don't know how to graph it, nobody cares. I just want you to draw a conclusion. You know, is it symmetric? Or maybe it's not symmetric. Whatever you want to say about the distribution of the data collected, but only based on those numbers, the mean, median, and the standard deviation. So this whole thing should take you about, I would say, no more than 20 minutes, 15, 20 minutes, okay? So this is your assignments for Thursday. I will see you then. Bye-bye.